Hello friends, today we discussed about a linear data structure which is named as stack. In the stack, what type of means data are stored in which manner today we discussed. Then a stack is a list of elements in which the data are inserted and deleted at any one end. Okay, here this one end is called as the top. So what basically here we discussed, that means stack stack is a means representation where we represent it into two types. One is a array representation, another is a linked list representation. Then later on we discussed about these two types of representation. Before that, so what do you mean by that stack and how in which manner we store and inserted here the elements and deleted that elements? Okay, so whenever here we insert and delete the elements, so at one end we insert and delete the elements and the end is here called as top of the stack. Here it is called as top of the stack. Okay, so here it is a linear data structure, and whenever we insert and delete one end, it is called as top of the stack. Then in which manner we insert and delete the elements? So here the principle in which manner we insert and delete the input here, it is called as LIFO, which full form is last in first out. Okay, so last in first out means whatever be the elements here inserted, okay, and that element is here stored in this, next element is stored in this, next is this, and which element here is inserted last. Okay, so that's why it is called as last in. That means which element here inserted last, that element here we out it first. Okay, so which element here inserted first, that element is in the below position, then after the next element, then after the next element, and which element here inserted in last, that element we here out it first. Okay, so what are the different practical example, real life example of the stack? Suppose we store here stack of books, stack of plates, stack of toys. Okay, so these are the real and practical life examples. That means why we called it as stack of books. That means one after another we store all the books. Okay, and whenever we just out the book, the topmost element, topmost book, first we here out, then the next book, then the next book, like this. Okay, suppose the stack of plates, okay, one after another different plates are here stored. Okay, so first the last plate which we out, then the next plate, like this. Okay, so the real life examples are here: stack of books, stack of books, stack of plates. Okay, next is stack of toys. So these are the real life examples. Okay, so next, what are the different operations here we are doing in that stack? Okay, so there are, it can follow here different types of operation. Here are we are doing different types of operations. Okay, so what are the different types of operations here you are doing in that stack? So first operation is here called it as push. Okay, so one operation is push and another operation here is called as pop. Okay, so what is the difference between that push and what is the difference? Now what do you mean by the pop? What is the difference between push and pop? Okay, what does it mean? Here I explain all these terms. Okay, So before going to the push and pop operations, so here basically in these two operations, so what we check, if the stack is full or not, okay, and if the stack is empty or not, okay. So there we are using here two concepts. First is stack is full or not, another is stack is empty or not. For that push operation, okay, so one concept is here we are using, that means the stack we check that if it is full or not, okay. For the pop operation we check that if the stack is empty or not, okay. So what do you mean by the push? Why we check it at the stack is full or not? Push means it is a operation where we add an element into the stack. Okay. So whenever we add one element, okay. So before that, first we check that if the stack is accept that element or not. Okay. So whenever we find out that the stack is full, that means already the stack is full, then next it cannot accept any element. So we check that full condition in that push operation. Okay. So next is another pop operation. So pop operation means we delete here we delete one element. So whenever we delete element, so first we check that if the stack is empty or not. If the stack is empty, okay, then already the stack is empty, so there is not any element. So here how we delete one element from that stack, okay, it is already empty. So in that case we check that the stack is empty or not in the pop operation where we want to delete one element, okay. So in that push operation, whenever we find that the stack is full, so we give one message that the stack is overflow. Okay, that means the stack is overflow. Okay, that means the stack is already full. Okay, and whenever in the we are doing any pop operation and we write down the stack is here under flow. Okay, so whenever we find out the delete operation and we are getting that the stack is empty, that means we write down one message that the stack is under flow. Okay, so these are the two operations here we are doing in the stack. So how we do that particular operation? Okay, so before checking that, first we write down what are the different representation of stack. So here I first explain about the array representation, then after another representation of the stack which is called as linked list representation. Okay, so there are two types of representation of the stack is there. One is array representation and another is linked list representation. Okay, so one is here one is here array representation, another here linked list representation. Okay, so before starting that, first we explain the array representation. Okay, so first we explain that array, then after we discussed about the linked list representation. Okay, so what do you mean by the array representation? Here in the array representation we know that the stack is a linear type of data structure. Okay, so we here find out there are two conditions, one is push and another is pop. Okay, and we know that whenever we store the array, so array indexing is there, the array indexing is starting from 0 to the maximum number of elements. Okay, so the maximum number of elements if it is given as max equal to 5, then we represent the array up to max minus 1, which is 4, because our indexing is starting from 0. 0, 2, we store the elements like this: 0, then next element 1 indexing, next is 2, next is 3, next is 4. So this is all about the array representation. Then here, how we represent the stack in that particular array representation. Okay, so here suppose we mention here the size of the array is equal to, here size of the stack is 6, size equal to here 6. Okay, so that means here maximum it can take up to 6 number of elements. Okay, so whenever the size of the array is mentioned here, it is 6 and it can take in maximum number of 6, 6 number of elements. Okay, that means whenever we are find out the maximum size, that means the stack is here overflow. Okay, this is all about the push operation. Okay, then whenever the size is minimum, okay, so here this is the underflow condition. So how we check that if the stack is overflow and if the stack is underflow? So here I explain all these things said in detail. So how we explain this thing? So look at this. This is one example. So here I am giving one example on the push operation. So here write down the push function. Okay. So in that push, what does it mean? Here the element we added. Okay, push means we just insert one element into the stack. So in the size of the means stack, here I given the size is here. Size is here. Suppose it is 6. Okay, so the maximum it is taken as up to 6 number of elements. Okay, suppose this is one stack. So how we push each and every element here, and what are the different elements and how we push it. So here one keyword we are using which is called as top. Okay, so the top position here, before inserting, first the top is initialized with the value of -1. Okay, so after that if we add any element, okay, so the top is here incremented, top equal to top plus 1. Okay, that means -1, first we initialize the value top equal to -1, and whenever it is -1, we know that the stack is empty. Okay, after that we increment the value top equal to top plus 1, then we insert the next element. Okay, so before that, first we check that if the top position element is equal to max -1 or not, max -1 or not. Okay, so maximum is the size, here it is given maximum size is what, 6. So this is your max. Okay, so we are given the maximum size is this. So first we check that if the top value equal to that max equal to, we just means check that if the value is same of that max -1 or not. Okay, so if the top is equal to max -1 or not, if this is so, okay, then we write down that the value here top equal to max -1, that means it can achieve its maximum position. So the next insertion is not possible, the push is not possible. So what we are write down? We are write down the overflow condition. Okay, but if this element is not that max -1, top is not equal to max -1, then the insertion is possible. Okay, suppose we want to insert here 10, 20, 30, 40, 50 and 60, because the maximum size is here 6. Okay, and here we indexing starting from 0 to 5. So max is here taken as 6 minus 1, which is equal to 5. Okay, so first what we are doing, we top equal to, first initialize -1, then top equal to -1, Then after we increment the top equal to top plus 1, that means it is 0. Then we insert the value. Then top is incremented by 1, which is 1. Then insert another value. Then top is incremented 2. Then we insert another value. Then is top is incremented here 3. Then insert another value. Then top is 4. Then insert another value. Then next the top is equal to 5. Then we insert another value. Clear? So after that, the max position it can achieve, the max minus 1 position. So maximum is 6 and max minus 1 equal to 5. So now the top value equal to max minus 1. That means now it can getting the overflow condition. Okay. So after that the insertion is not possible. Okay. So how we write down that particular algorithm? So write down the algorithm first. Then we check according to that algorithm. Okay, we here give another example and we check that if the algorithm is here properly working or not. Step 1 here start. Okay, step 2 we write down that if top, okay, so it equal to either you are write down max minus 1 or size minus 1, whatever may be. Okay, you are write down this. Then if this is so, if top is equal to this thing, okay, then write overflow or stack is overflow. Okay, then step 3. If the stack is overflow, then we are going outside of the loop. But if it is not overflow, okay, then what we are doing in the else condition, you are write down the else part also. So in the else condition, you are write down else. So this is your 3. You are write down here a different number of statements. So you write down like this 3.1. Okay. So write read element x. So which element here you want to insert it? You write down this element. Then another statement you write down top equal to top plus 1. I already mentioned this thing that top equal to top plus 1. Then another you are write down stack top is equal to x. That means whatever be the element you want to store, you write down there. Okay. Then step 4. Exit or end or stop, whatever may you write down. Okay, so what is the basic thing here? You means understand that whenever the top is here size minus 1, okay, then next the insertion is not possible. So look at this. This is the condition. So if top equal to size minus 1. So what is the top value here? Top is now here. Top is now here. Okay, because in each and every case the top is incremented. Top equal to here 0, here top equal to 0, here top equal to 1, here top equal to 2, here top equal to 3, here top equal to 4. So whenever the top equal to 5, that means the size is here given, size is equal to 6. Okay, so size minus 1 equal to here 5. So that means you know that this is the overflow condition. Okay, else what you are doing? Okay, suppose this is not the overflow condition, then what you are doing here? Okay, so this is not the overflow condition. That means all the elements are not in the list. Okay, so what you are doing. Suppose only one element is there or the stack is empty. Okay, so if any one element is there, that means the top position is equal to now 0, because previously the top is initialized with -1. After insertion the top value is incremented. Okay, so how after insertion the top value is incremented? So this condition is not satisfied. Whenever only one element is there, this condition is not satisfied. So what we are doing? Else read element x. Okay, suppose we want to insert 20. Okay, so what we are doing? We read that 20 and then top equal to top plus 1. So top value is now 0. Okay, then we increment it to top plus 1. So top value is now what? Top equal to 1. Okay, so stack top. That means stack is the name of the array. Top is the index value. So top equal to 1. So stack 1 we store the x which is equal to 20. Clear? So next what we are doing here? Next we once again same thing. We check that if the top is equal to size -1. Here it is not size -1. Okay. So once again we go to the else part. Read the element. So the element now we read next is 30. Okay. And top equal to top plus 1. So top is now equal to top plus 1 which is 1 plus 1 which is 2. Now we store the 30 and stack top equal to that 30. So that stack and 2 is equal to 30. We store it. Okay. So once again we check that if the top is equal to size -1. So this thing is not here satisfied. Once again go to the else part. Then we store it. Once again we check and go to the else part. Then we store it. Once again we come here and check. So here the top value equal to 3. Here the top value equal to 4. Here the top value equal to 5. So whenever it is 5 and we store 60, after that whenever we go to this line, if top is equal to size -1, okay, then what is the answer? It can write overflow. Okay, so this is all about the overflow condition. Okay, that means now the stack is here full. Okay, so this is all about the push operation. Okay, so whenever we write down the push operation, so we first check what is the condition. We first check the condition of stack overflow. Okay, so if it is not full, then we insert the next element and we increment the top position. Okay, so like this we insert one by one the next elements. Okay, so this is all about the technique of the push operation in that stack. Then in the next video we discussed about the pop operation. Thank you.